You've perfected your product design, but the first batch of plastic parts arrives warped, cracked, or marred by sink marks. It's tempting to blame the factory or materials, but often the real issue is in the design itself. Digital models can hide problems that only appear during molding, like sharp corners causing cracks or thick sections leading to sink marks. These aren't random defects, they're the result of ignoring how plastic flows and cools. Manufacturing is a negotiation between your design and physical reality. If you don't account for the behavior of molten plastic, the material will win, warping, shrinking, and cracking as it pleases. Mastering design for manufacturing, DFM, is essential to avoid these pitfalls. By understanding a few key principles, you can design parts that are robust, attractive, and easy to produce. This proactive approach saves time, money, and frustration. It turns guesswork into predictable results, ensuring your vision becomes reality. The secrets are simple, but they make all the difference. Draft angles are a basic but critical feature in plastic part design. A draft is a slight taper on vertical walls. Think of the slope on an ice cube tray. Without draft, parts stick to the mold, causing damage or defects during ejection. 1 to 2 degrees of draft per side is a good starting point. Textured surfaces or certain plastics may need more. Adding draft is easy in CAD and prevents common molding issues. It ensures smooth ejection, protects surface finish, and extends mold life. A small design tweak, big impact on quality and cost. Uniform wall thickness is vital for strong, flawless plastic parts. Thick sections cool slower, causing sink marks, warping, and internal stress. Thin walls can lead to incomplete parts or weak spots. Stick to the recommended wall thickness for your material. Need more strength? Add ribs or gussets instead of thickening walls. Ribs should be about half the main wall's thickness to avoid defects. Consistent thickness ensures predictable cooling and a stable, attractive part. It's a simple rule that prevents most molding headaches. Design smart and your parts will look and perform better. The simplest molds are two-part tools that open in a straight line. Undercuts, features that trap the part in the mold, add cost and complexity. Avoid undercuts when possible by rethinking features. Use U-shaped cutouts or through holes instead of side holes. If undercuts are necessary, design them to minimize extra tooling, like adding slots next to snap fits. Every undercut increases tooling cost and slows production. Analyze each feature. Is the undercut essential or can it be redesigned? Clever design can maintain function while keeping molds simple and affordable. Less complexity means faster, cheaper, and more reliable production. Even the best design fails with the wrong plastic. Match material properties, strength, flexibility, heat, and chemical resistance to your product's needs. ABS is tough for electronics. Glass-filled nylon is strong. TPE is flexible. Polypropylene is great for living hinges. Consider environment, UV, chemicals, and temperature all affect material choice. Manufacturing properties matter too. Shrink rates and flow impact mold design. Consult with suppliers and molders to pick the right resin for performance and production. The right material is the foundation of a successful plastic part. Once you've selected the right material and perfected your design, it's time to put your plastic part to the test. Quality and durability aren't just buzzwords. They're proven through rigorous testing. Start with basic visual inspections to catch obvious flaws like warping or sink marks. Next, move on to mechanical tests. Tensile strength tests pull your part until it breaks, revealing how much force it can handle. Impact testing simulates drops and knocks, ensuring your part survives real-world mishaps. Don't forget environmental testing. Expose samples to heat, cold, moisture, or UV light to check for fading, cracking, or deformation over time. For parts used in critical applications, specialized tests like chemical resistance or fatigue cycling may be necessary. Testing isn't a one-time event, it's a continuous process. By catching issues early, you save time and money and guarantee your plastic part performs as intended every time. That's why I created my full online course, Design for Injection Molding. This course includes 18 self-paced modules, expert videos, and practical design tools, built from my 30 years of engineering experience. Whether you're new or experienced, it'll help you design smarter and avoid costly mistakes. Click the link in the description or visit courses.3ddfm.com to get started today. Don't guess, learn it right, and make better parts from day one. If you found this video helpful, like and share it with a fellow designer. Let's build better parts together.